Hello, I'm Laura Lewis, and this is exam practice for planning work for practical assessment. Let's make sure I'm not on mute there. No, you can hear me. Okay, so as part of new exams, well, it's been around for about 3 years now. I say new. I'm teaching a while. Part of new exams that instead of having coursework in your examination, what you have is exams that you do in class, and you can be asked about them in the examination. So something to really be sort of scared of, okay, because they're called required practicals. You've watched someone do it, or a video or something like that, or planned it yourself. Okay, so it should be sort of vaguely familiar. I know people forget, but you're vaguely familiar with the format of it. Okay, so yeah, it's not nowhere near as bad. It's very easy marks you can gain from this. So yeah, I chose to make a video about this because yeah, it's easy marks that people can miss out on because they just look at it and they think it's more complicated than it really is. Okay, so I think the best way of doing it is obviously do examples. So I've taken some questions out of exam papers and we're going to go through them today. Okay, so let's start reading. These are 6-mark questions, unless stated otherwise. And if you sit at the beginning of a question, in this question, you will be assessed on using good English, organising information clearly, and using specialist terms where appropriate. That definitely means it's a 6-mark question before you even see the 6 marks, because it means you have to write things to make sense. If you just write words, yeah, you're not going to score many points. Okay, you have to write a sentence. You don't have to write an essay, but you don't have to write more than just words. Like sometimes you get a question where even just giving one word, like yeah, like saying, I don't know, sulfuric acid, that'll give you 1 mark. But this one you have to write full sentences. Okay. And you get them in biology, you get them in physics, and you get them in chemistry. We're looking at a chemistry one today for practical assessment. Right, let's have a look at the content. So it says the salt called potassium chloride is made when potassium hydroxide solution reacts with hydrochloric acid. So let's have a look closely at this. So potassium hydroxide, if you see the word hydroxide, it is alkali. Okay, hydroxide is an alkali. Hydrochloric acid, obviously an acid is an acid. Okay, so an acid plus an alkali, so an alkali plus an acid, doesn't matter which way around you put all of them, that is a neutralization reaction. Okay, neutralization, because yeah, they're going to become neutral solution if you add the right amount. Okay, so out of this, you're going to get potassium chloride. The potassium chloride is very similar to sodium chloride, and sodium chloride is table salt. So this is a salt. Anything with the word chloride in it is a salt, a type of SaLT, a salt, plus water. Okay, so all neutralization reactions, you create water as well. Describe a method for making crystals, and that's in emboldened, of potassium chloride from potassium hydroxide solution and hydrochloric acid. In this method, you should describe how you would add the correct amount of hydrochloric acid to neutralize the potassium hydroxide solution. So, giving you a clue there as well. We didn't spot it the first time. And describe how you'll get the crystals of potassium chloride. Okay, so there's a few things you can do here. Sometimes you might know it as a titration. Okay, so let's write that keyword down. A titration. There's a titration neutralization reaction. Sounds more complicated than it is. What it means is adding acid to an alkali very slowly. Okay. So I'm going to say the exact right way of doing it. The good practice way is to put the acid in the burette. Okay, the reason why is because acid's easy to clean, but the mark scheme is you can actually put either of them in the burette, so you don't worry about getting them mixed up. I'll just say the good practice way if you're working in the laboratory, but if you get them mixed up, you still get the same amount of marks. So you will put, so what I'll do, the plan. So add, let's give an amount, centimeters cubed. There's a volume of potassium hydroxide to a beaker. Okay. 1. So we need to know the pH of it. Okay, so I would add universal indicator to tell us the pH. Okay, so as it's alkali, it should be sort of dark blue to purple. Okay, so what you obviously mix the solution. You could have any. I'm going to put something here actually, so because you get marks for other things. So marks would be given for other indicators, such as phenolphthalein. Okay, or methyl orange. You may have seen in class. Okay, you may have seen one of those. You wouldn't really use a paper one because it needs to stay in the actual mixture. Okay, so I'm going to just need to correct my spelling there. So it's phenol. Okay, don't worry too much yet, as I said, about trying to spell it. They'll know what you mean, and it's quite an odd word to spell. Okay, phthalate or methyl orange. Okay, or universal indicator. Yeah, don't worry about spelling. Just any indicator is fine. I'm just saying you may have seen other indicators other than universal, which is also fine. Okay, mix the solution. So make sure that the indicator is mixed in. So place under burette. It's one of those long glass things with a tap. Okay, place under burette. Make sure burette got one tap is closed, and fill the burette with hydrochloric acid. The burette's got numbers on the side to tell you how much is in it. Okay. Okay, fill the burette with hydrochloric acid. So add a little. I would also place a white tile under the beaker. Okay, because maybe we can see the color a bit clearer. If the table was white, it might be okay, but I'll put a white tile just to make it clear to see the color change. Okay, it's to see the color change clearly. Okay, so add a little acid at a time. Don't like pour the whole lot in, and observe color changes. So slowly add the acid until the solution changes from purple to light green. This is the case of universal indicator. If it's phenolphthalein, it will go colorless. Okay, so I'm basing it on what I've wrote about. So check indicator chart. Okay. The green color will show. Oh, it colored twice. The green color will show the neutralization. Okay, right. So we got one bit done. Okay, so what we need to do is to make it pure. So note down how much acid has been added. Okay, so repeat the procedure without indicator and the same, let's just make it pure, and the same amount of acid. Okay, so pour the neutral solution into a basin or a dish. Okay, and heat the dish over a Bunsen until liquid has evaporated. Okay, then you leave to crystallize. It could take a few days for crystals to form. They could form quite quick, or they could take a little while to crystallize, okay, to form. Okay, so that's our full answer for that. It's not as bad as it seemed for most people, is it? I don't think. Okay, so a bit more practice. We'll look at another question, similar but different. Okay, again, the one, oh, we've got some pictures this time. So here's a burette, there's a conical flask, there's acid. Okay, because you could put it in a conical flask actually rather than a beaker, but it doesn't really matter. In this question, you'll be assessed using good English again, organising information clearly, and using specialist terms where appropriate. So it's another 6-mark question. The student used the equipment shown to do a titration. There we go, got my white tile there. So this is a pipette, a pipette filler. So that's like a bulb thing. You might not have used one of those before. Sodium hydroxide, some sort of acid, we don't know what it is. Indicator, burette. So it says describe how a student should use the equipment. So it's the same sort of thing again. Describe how a student should use this equipment to find the volume of sodium hydroxide solution that reacts with a known volume of acid. So they're doing it the other way around. Okay. Yeah, I said it didn't really matter too much. It's just about the cleaning afterwards. Because I've worked in the laboratory. Okay, so let's just I'll put this up the page a bit so we've got a bit of room. Okay. So do not describe how to do any calculations. Okay, so we need to really describe kind of doing the same sort of thing again. We've got a little bit of extra equipment, a little bit different equipment. So we are going to, it's kind of actually more basic, really, isn't it? We actually told all the equipment. So actually a more basic question. So some of these 6-mark ones are actually pretty fairly easy, aren't they? Okay, so let's just do it again. So add the acid to the conical flask. Measure this out. Measure this using a pipette and pipette filler. Yeah, it's just sort of like a squishy bowl, but you push and then sort of it will and you release it and then it will it'll sort of like draw the liquid. Like pipettes are in glass, and they will draw the liquid up. So you may have done it in class, you might not have done. Okay, but you don't need to have done it. It just needs a pipette is filled with that pipette filler. That's all it does. Okay, you might have used an automatic pipette if you've got a lot of very nice equipment actually. Okay, so add a few drops. You don't need much. A few drops of indicator to the conical flask. So it goes in the conical flask, not the burette, as we said before. Okay. So add sodium hydroxide to the burette and place the, again, make sure the tap's closed. So yeah, like I said, make sure the tap's closed. Place the conical flask over the white tile. Okay. Again, with indicator, you'd be allowed to write any indicator there. They will not discriminate over it just as indicators, isn't it? Okay, add a little sodium hydroxide at a time to the acid and swirl around. So yeah, make sure you mix it all the time, because sometimes it will change colour for a bit and you swirl it and then it changes back to how it was, and swirl around. So if using, well, I can't spell, phenolphthalein, okay, it won't catch me that time. If you're using phenolphthalein, the neutralization point would be reached when the solution is colorless. Okay, so that's another thing. Okay, another indicator, apart from universal indicator. So if using phenolphthalein, neutralization point will be reached when the solution is colorless. Okay, so note down how much sodium hydroxide, I can think which we're adding to what, because in one question it's one way, wasn't it? Hydroxide is added to the acid in a table. Repeat, so yeah, if you're going to be obviously very scientific about it, repeat the procedure 3 times and take an average of the volumes to find out how much sodium hydroxide is needed to react with an acid to achieve neutralization. So yeah, there are a few things for neutralization reactions. What about burettes? Yeah, a lot of people forget the names of these things. So that's very long. It's with a glass, called a burette. Conical flask is conical. A beaker is what a beaker is, but a beaker is a bit more like a normal glass. Yeah, indicator. And you get marks actually, yeah, for saying any of the indicators which you set up here about methyl orange or phenolphthalein or universal indicator. So in this one was a bit different. So about how to get crystals, and this one was actually a bit more basic. This question just asked about, if you go back and have a look, just asked about how much sodium hydroxide would be required to react with the volume of acid. Okay, include any measurements the student should make. So yeah, repeat the volume. So you need to note down the amount of volume added. Okay, so these ones, so I'll read off the mark scheme. So it's level one or 1 to 2 marks, because there is a simple description of using some of the equipment. 3 to 4 marks, there is a description of an experimental method involving measurement or including addition of alkali to acid. And for our 5 to 6 marks, obviously what we're trying to get, there is a description of a titration that would allow a successful result to be obtained. So we've outlined that. I'm just going to put in here as well. So this is also a titration. So that's a word you need to know, keyword, titration and neutralization reaction. Okay, so yeah, that's answered both these things. Okay, just things to be aware of here. So in general, yeah, if you add an alkali to an acid, you'll get a salt plus water. You could put at the end here, not C2 neutralization in a neutral, just to remind us, in a neutralization reaction, a salt and water is produced. We've got some think of salts that you put on chips, but a salt is a nitrate, a chloride is good because salt that you put on chips is sodium chloride, but any chloride is a salt. Salt and water is produced, and with evaporation, Okay, crystals could be produced. There's a bit of an extra thing here. Okay, so that's introduction to obviously assessment, practical assessment. Yeah, it's not as hard as probably you thought it was at all. I'm just describing how we do the experiment. Okay, so obviously feel free to go back and to watch video because it's all recorded. And I hope you've learned something today, or it reminded you of something. And thank you for joining this class, and hope to see you in another video. Thank you. Goodbye.